Hi there, welcome to the channel. So today we're going to be talking about the transformation priority premise and then use it to write a sorting algorithm and hopefully end up with Quicksort. One of the interesting properties of TDD is that it gives us no guarantees about the efficiency or performance of our code, only that it has a certain behavior. There are ways you can obviously assess the performance, but what if there was a way to iteratively construct algorithms that will tend towards the optimal solution? Another common problem with TDD is that you write yourself into a corner and then you require a lot of time in the red phase of the red-green refactor cycle while you restructure your code to pass the next test case. As we know with TDD, you want that cycle to be very short, so we want to avoid those rewrites as much as possible. In this blog post, he defines a code transformation as a change to the code that actually changes the code's behavior, which is distinct from a refactor where the behavior is supposed to remain the same. He suggests that not all transformations are equal, and that if you prioritize certain transformations, you should avoid or minimize those problems. He openly admits towards the end of the post that his list is likely wrong or incomplete or poorly named, but nonetheless there seems to be something to it. In the talk I watched where he introduced the idea, he left it as an exercise for the audience to try this with Quicksort, so I thought I'd give that a go today and see if it comes together. As we see in here, he starts with this line, as the test gets more specific, the code gets more generic. That's one of his fundamental rules of TDD that is not well captured by red-green refactor. And here he goes through some examples, and this is his list of transformations. Okay, so here we go. We've got our sorting test suite here and our sort code in here, and then this is our test suite. So first of all, let's do the most degenerate test case and try and sort an empty array. Okay, so if we run that, that's going to fail because we don't have a sort function yet. Going to import that from our sort TS. That's still going to complain because we don't have a function in here. Okay. Lovely, that's our first degenerate test case. So now let's see if we can sort an array with a single item. So if it has 5 minutes, we should expect to get back the same array. Cool, so we're in the red there now, so this doesn't work. So if we look at Dr. Bob's thing, what we've got at the moment is either nil or a constant, depends how you want to look at it. And so if we go down here, we can make this test case pass by turning a constant into a variable. So if we just return input, there we go, so sorting a single item array. Okay, we can see quite far down here that an assignment is very low priority, so I'm going to say kind of arbitrarily that our sort algorithm, we don't want to modify our input array. Okay. Okay, so I can put whatever I want in here because I'm not actually going to test the output, I'm just testing the input has not changed. Let's mix this up actually. Okay, so we got two arrays that are the same. We're going to expect, if we sort input, we don't care what the output is, we're going to expect that the input okay, so that actually passes already, which is good. And it means that we're going to hopefully avoid that case, at least in the return value. Okay, so now what's our next test case? Well, we're going to have a 2-item array. That's definitely the next thing. So let's sort start with an already sorted one. So 5 and 10. Okay. And then now we're going to have our array with 2 items out of order, unsorted 2-item array. 10 and 5. Okay, so now we have to modify our code here. So we know for an empty array and a single item array that this already passed, and so we need to care about this 2 case first. So I'm going to say that if the input length is less than 2, we're going to return the input there. And so that means that those test cases should be unaffected. And it's just our one failing one still. Okay. So our transformation there was this unconditional to if. We're going to split the execution path. And we've also introduced a constant here of 2. So we've done 2 transformations in there, I suppose. No, actually really just 1. Okay, so our unsorted 2-item array, let's extract that, because we need to know what these are. So here we are creating a variable, and then we're going to say if a is greater than b, I'm going to return b and then a, because we want the smallest first is what we're expecting. So if a is greater than b, then a goes second, else return ab. Okay, and you know, we're going to do our refactor step, maybe that as well. Okay, lovely. So let's do our 3-item array. Okay, so we're failing to sort an already sorted 3-item array. So how can we make that pass? Well, what if we used b as an array? So we'll take b out, and we'll say if we've got this one here. If all the items in B are greater than A, then we'll do it this way. So we've converted our scalar to an array here. That was our change. And now we've got to figure out what to do here. I think these variables in general, we're going to have to make those arrays now. So we want to put all the ones that are greater from this B side, sort of to the right of A. We want to put all the ones that are greater than A to the right of A, and all the ones that are less than A to the left of A. So let's write that. So okay, so smaller than A. And then we also need to have the greater than or equal to case. Okay, and then we can kind of rewrite this because we've got an array that's smaller than A, an array that's bigger than A. So that we can just, drop those in there. Okay. So we're sorting an already sorted 3-item array. Let's see what happens if we have an unsorted 3-item array. So judging by this case, we're just going to move all the values kind of in order to before and afterwards. So one case that we could see might work already is if we had the middle value at the start of the array. So why don't we try putting 10, 5, 15. So it's an unsorted 3-item array. Interesting. Okay, so we got that working. Let's try with a slightly different one, maybe 15, put that at the end. Maybe 15 there and 10 there. Oh, okay, so we've got a failing case. And that's because these are unsorted. So we know that it will work in certain cases, and it will definitely work in a 2 case. We've seen that it definitely works for the 2 case. So these arrays are going to be smaller because we're taking at least one item out from one or the other. And if we look down this list, that a statement is best if it goes to recursion. Okay, so why don't we try sorting these. Okay, so we've got our unsorted 3-item array. Let's try some bigger ones. I don't know. Okay. Okay. That's good to know. And I think, at this point we could keep going, but I think we've got a working algorithm. So now we can kind of refactor this a bit. Let's call these a bit better. Maybe let's call this the pivot. So putting that in the middle. I'll still pass this. Let's call these the rest, because they're the kind of rest of our numbers. Save that, still passes, good. I kind of don't like that this is the way it is, so maybe we can create a reducer or something to put that into one line. So okay, so we've got some condition on which array it should go in, and so this is going to be a function that will take a number and return a boolean. Then what we're going to get back is two arrays of numbers, right? Actually, we're going to get back a reducer that will give us that. This is the form for the reducer. I'm going to say if the condition is passed, we're going to return an array here with that element appended to it. Otherwise, we're going to return that's actually, this is the give me a t. It's going to be a number. It's going to be an array of whatever type t. So what we actually got here is a reducer over numbers. It's going to give us throw in some generics, why not? So we've got a partitioned array. Of type number, okay, so we're taking our array in, and we can actually, why not, make this whole thing nice and generic. Cool. So we're going to rewrite this a bit. I'm going to have that's going to be equal to the rest of our stuff, and we're going to reduce it with our split array and our condition things to get in the first one. It's going to be that. So it's going to be our small array and our large array. And then we should be able to move those. And notice this is all a refactor. You know, we don't have a broken test. We're not in the red stage. We're in the refactoring stage. So I can get rid of that and say smaller. Cool. And so now we've kind of got this to a point where, you know, we could even start looking at making this sort function generic, because we are now able to have this condition. So we could, you know, pass that up and create more complicated sorts for things that aren't numbers, for example. Got this nice partition. Not using those. So, you know, this is extra stuff that I think makes it more readable, and it reduces the fact that the less than and the greater than have to match. You know, that can't be a problem now, because anything that doesn't go into the first array will go into the second array. So a few opportunities for mistakes there is the only reason why I really restructured that. And there we go. We've basically got Quicksort in 4 lines. So that's the end of the demo, and we have a working Quicksort. So my overall take with TPP is that there is something to it. I think what it's fundamentally getting at is that TDD isn't the brain-dead process that it's made out to be. The choices that you make of what to test and what incremental steps you take fundamentally impact the structure of your code and the solution. It's okay to pick contrived and less general test cases in order to make certain small transformations and incremental progress. A lot of people shy away from that. You know, I specifically chose a contrived version of the 3-item array problem because I wanted to make that small transformation and prove that it worked in that way. I didn't jump straight to any random 3-item array being sorted. So to summarize the principle in my view, the purpose of the test and doing TDD is to prove that the current solution is insufficient in such a way that fixing it will require the smallest transformation to the code possible. And what those transformations and steps actually are is up to you. Well, I hope this has been interesting, and thank you very much for watching.